Welcome to Hobby Halloween. This video serves as an introduction for those who are new to pneumatics and seeking guidance on how to start creating Halloween props with them. For first-timers especially, I recommend buying kits that include all the pneumatic fittings, brackets, and components designed to work together. I've ordered my pneumatic kits from Scott at Fright Props. The link is in the show notes below. Over the years, I've collected a lot of different pneumatic fittings, hoses, cylinders, for various different reasons, and I discovered that there's a very frustrating collection of things that you need to know. Like, for example, these may look like the same kind of connector that goes on the front of these cylinders, and there's things in the back. You can see that some of them are wide, some of them are narrow, some of the pins are smaller, and some of them are longer, and each one of these has a different thing in the back that needs to be connected. This requires metric bolts. This requires the imperial connections, hence they had the good sense to put on there that these were imperial threads, so they would go on there. So this particular one will not go on there. It looks like it will thread on there, but then it'll only go on so far, and then it gets jammed up like most metric and imperial or vice versa happens. I have all different kind of fittings. The black ones here are 1/4 inch. The white ones are 6 millimeter. You can get some of them that are at 90-degree angles. You can get all kind of different couplers, adapters, T's, Y's, valves, like these inline valves here, different kind of mufflers with some adjustments on them, like those right there. They have different solenoids and different ways of connecting the solenoids. This one here just says wired ends. This one here, you have to put a wire in and connect them up inside this block. You have different ways you can rotate these things. The input fittings are all different. If you're not careful, you can buy the wrong ones. So let's go over the different components. Let's start off with the basics of what they are. So a lot of the tutorials about pneumatics will start talking about the different lengths of these and the different diameter sizes of them. They call the length of how far out this rod will extend. It's called the stroke, and the size of these are called the bore. In other words, how much air they can move. The bigger the bore, the more air, the more power. These cylinders need to be connected in the front and in the back, depending upon if you need the back to pivot up and down. If this is pushing out forward and something is moving up, and then when it's coming down, it's going back to being level again, you need this back to pivot. For that purpose, they have these pins that will go through these brackets, and I would put them in there like that, slide the pin through, and then they have a E-clip on either side of them. I'm not sure that's the one that goes with it, but that's the idea. You would slide that in there, and with pliers you'd push that in there, and that would secure this to the back. So another attachment option is to bolt this, and so the nut that they have here will also thread on the back here. So that's another alternative to that. They have these brackets that you can get, like these brackets here, that have a hole that the cylinder fits in, and then they've got some mounting holes on the side. Obviously, that's a small one. I won't fit this one. For the end of the rod, they also have these different sort of attachments, and again they have a similar pin that goes through. You take the little E-clip out, and then you can attach this to whatever you need to attach to. This will allow that to pivot. This threads on to the front, and keep that nut, and they can jam it together, and that will keep it attached to that. These are kind of neat. I like these. These are like a quick disconnect. But that comes off, and then you have your pin that can slide through. So this provides a quick disconnect. You slide your pin through, and then this. Trying to find the right attachment hardware can be difficult. It's sort of like a Goldilocks thing. Whereas you can see this is the large one, this is metric, this is metric, this is imperial. So you have different sizes of threads and different thread standards. And then for the pins, you have small, medium, large, and not only that, but you have longer pins that need to go through here, and different diameters and different bracket types. That's why it's easier to buy a kit online where all these purchasing decisions have already been made, and you don't need to have a whole bunch of stuff when you're starting out. You can just buy a kit. It'll come with everything, all the fixtures and fittings will all fit, and you don't have to worry about trying to match these up separately. Especially if you just buy the cylinder and it does not come with these things. Resist the temptation of blowing your air in there, because your moisture from your breath will be not a good thing. You don't want them to get internally contaminated. Okay, well let's go on to the next step and figuring out how we connect the cylinders up to the air supply. We do not do that directly. We're going to use something called a solenoid. Now, a solenoid is simply this. It's a coil of wire. And in this example, this block here contains several windings of wire, and it magnetizes this part of the valve. This valve takes air in from one direction and directs it out through A or B, depending upon whether the valve is energized or de-energized, the solenoid coil, that is. And you'll see that these go on a very specific way. You try to put them on the other way, they usually are blocking you. They want to specifically go on that direction. So, and they make different sizes of those. They'll have the different fittings. These are 1/8 inch. I bought the wrong size. I don't use this size, but I made a mistake. I got this one off of Amazon, and this is the correct size. And you get the fittings that will be for your hose type. The black fittings, they'll say 1/4 on them, and that's a 1/4 inch. So these are for 1/4 inch tubings. I went and I bought these white ones thinking that I was getting a deal, and it has a 6. That's 6 millimeters. Now they look almost identical when you compare the diameters to these, but you'll find out very quickly that if you try to take the 1/4 inch tubing and put it in there, it won't seat in there properly, and it doesn't work. It'll leak, it'll come apart, it doesn't work. So that's another lesson learned. So let's see how these work. Now these are called interference fittings, and what interference fittings means is that there's a lot of little fingers that go all around the diameter of that hose. So when I push them in, it'll allow me to go past those fingers, but if I try to pull it back, you can see that as I try to tug on that, that won't come off. What you do to release the tubing is that you have to push this little donut like that, and you can hear it go in, and then it will release it freely. One thing about the tubing that you need to be aware of is that they need to be square cuts. If you are trying to cut these with scissors or something that's not a proper tool, and you put them into the interference fittings, you can get leaks, air leaks from them. So let me grab a tool. So I have one of these tools I got off of Amazon. Again, they're not very expensive. And you put the tubing in, and what this will do is when you push down on the tubing, it'll cut the tubing off and give you a square end that you need. Now I have different kinds of tubing. I have this kind of tubing. I think this is a 1/4 inch. I have this kind of tubing, and I think this is also 1/4 inch. whatever tubing you use, you have to make sure it's the same as the fitting. These are 1/4 inch, this is 1/4 inch, so that's compatible. Let's wire up one of these solenoids. Now in this case, the wiring has a plus and a minus, and I've wired them up. I've wired the white wire to the plus side and the green wire to the minus side. And I'll be connecting that up to 12 volts, as this is what this solenoid requires, is a 12 volts. It'll work a little bit under and a little bit over. Nominal voltage is 12 volts. And same with this. So I like working with low voltage. They do make 120 volts. They do make other coils operating at different voltages. I think there's 24 volts, and there might even be a 5. Don't quote me on that, but you can operate at whatever voltage that this says here to operate on. So I have already installed all the fittings. These two fittings in the front here go out to the cylinder. This one here in the middle accepts the air from the compressor. And these are the mufflers, and they also have these little thumb screws that you can turn, and that will adjust how much back pressure is allowed to escape. That'll control how fast or slow the rod and the cylinder will extend out or come back in. If you open them up all the way, it'll go really fast, and if you pinch it off all the way, it won't even close at all. So you have to have it open a little bit, or else it won't work. So let's put some air on this thing and show you what that's like. Oh, there's one other little detail. There's usually a button. Sometimes it's a red button, sometimes it's a little silver button, and if you push that button, that will manually operate the valve inside the solenoid body. Even the little one has something very similar right there that you can push, and it will. So I'll put the tubing in, that's the input. So how do I get the air from my air compressor into the solenoid? Well, I need one of these quick disconnects. On the other end of my air hose, I have something that will plug in there. Notice I have both these types. That'll both connect to my air connector, but then I have a threaded inside and outside threading. I'm going to use this one, and I'm going to pair it up with one of these. Let's get one of them out of the bag here. So if I was just going to connect these two together, that would be fine, but I like to install a valve in series with my connection. So I'm going to put the quick disconnect for my air compressor on this side, and I'll put this on this side that will accept my 1/4 inch tubing and will go into my prop. But I want to put some Teflon tape. Now, when you screw these together, notice that I'm turning it this way. So what I'm going to do when I put the Teflon tape is I'm going to put it in the same direction that I'm tightening that on. So I tighten it on that way. So if I put it on this way, when I try to tighten this on there, it will actually be loosening up. So I want to make sure that I'm going in the same direction. I just only need 1 or 2 wraps around the body of this, like that. And then to break it off, I'm just going to pull it tight. Put that away. Another thing is, you do not want these little strings of the Teflon tape to be inside, because that would then get inside the air line and clog it up and contaminate it. So just keep the strings out of the way. And I'm going to use 2 pliers, and I'm just going to tighten that up. And you want it snug. You don't need to go crazy and over tighten them. Yeah, that's pretty good right there. So that won't be a source of air leaks. Okay, and then we'll put the other one on. Oops, get the handle out of the way. Let's put the other one on. And I'll get it started. And why won't that go on there? Have I got the metric confused? So this is a prime example of what I'm talking about, the imperial versus the metric. And when I was going to put this together, I found that this particular arrangement of quick connect and valve is a 1/2 inch, 20 threads per inch, which is pretty standard. I went to use these out of my kit thinking that they were the fit, and they seemed to go on, and then they seemed to stop right there, and I was thinking, what was going on with that? I found out that these are an M14 by 1.5. This is a metric. So this threads into a metric, and it does not thread into this at all. So what am I going to do next? I guess I should go through my collection and just see if I have any of these particular connectors that will go with what I'm doing here with the non-metric stuff. It's interesting. This is a 1/4 inch tubing, so that's imperial, and this is a metric on that side. And they even have smaller ones like that one. That one's particularly small compared to the other sizes. So that's kind of a bummer. You can have all of these different fittings and attachments and everything, and you don't have the one that you actually need. So since I have other props that have already solved this problem, I'm going to go ahead and just steal one off of there. Okay, so I'll just set that aside, and we'll use this one. This one already has a interference fitting on the back of the valve. I put it in there like that, and it's got the 1/4 inch tubing. It's in there firmly. When I turn this valve in that direction, it is now closed, so when I put air on it, it will just stop right there at the valve and not go through to the rest of the way. I like to do that when I put the air on the prop, and that way I can control when I want to pressurize the line with this valve. Just the way I do it. You can do your own way. So let's connect the A and the B outputs. Let's clear this off of here. And let's connect these two output ports to these two input ports. Okay, let's take a little too short, it's a little too long. Alright, well why don't I just cut this one in half? I got a lot of this clear tubing. Make sure that there are no edges in there that can get contaminating to that. So let's just plug, I don't know, let's plug that one in there. And plug that one in there. Now when you push in, make sure it goes all the way in, and then give it a gentle tug. Just make sure that you haven't, you know, if I put it like that, it can come out. So I don't want that to happen. Okay, let's get some air. I need to charge up my air compressor. So this is the air compressor that I have. It's a California Air Tools. It's supposed to be quiet. It's still noisy, but it's quieter than some of the other air compressors. It has your air tank pressure over here. It has your line air pressure coming out, and then it has a regulator so that you can dial up or down that you need. I'm going to turn it on and charge up the tank. Alright, so now the tank is fully pressurized, and I'm going to dial my air pressure down to about maybe 50 psi. You want to do your air line as low as possible to achieve the effects you want to achieve. And if I were to put that much pressure in that cylinder, it would jump out of my hands. It could be very harmful if I'm not careful. So I'm going to put it down at a safer level, and we're going to take this hose and we'll connect it up to the solenoid and see what it does. Okay, let's connect this line up. Now, the way you do this is that this little barrel has a little spring action there, so when I push in there, you want to help it in there. Now, I recommend when you're connecting or disconnecting this that you hold on to the connection, and I pull this back to release it. If I don't do that, and this has got a long enough of an arm, it can shoot out of there at high velocity, and this end will often hit you in the face. So that would be very bad. Now, the second thing to be aware of is that when I turn this valve, I'll be putting air into that solenoid valve. Now, I don't know which way this is configured. So if I turn on the air, this may actually fire as soon as I put air on it. It didn't. But if it does, that means I have these reversed. Get the wire out of the way. So let's try pushing the test button. All right. So that's how that works. That's the manual button there. But when we connect up 12 volts to this line, we can then effectively act as if we were pushing the button. But this could be triggered from a prop controller, from an Arduino, from a button, from a motion sensor, and that will effectively be as if I were pushing the button. So turn off the air, and you think that it's safe, but it's not. It's still, this is still having air in it. Watch. There we go. I bled it out. So just because you turn the valve off doesn't mean that the prop doesn't have some air in it. It can still move on you unexpectedly. So let's get this wired up to 12 volts. The way I'm going to do that is I'm going to put a connector. Now, I've had these connectors from Amazon where you have little screw terminals. Bring that in there closer so you can see that, and you can screw your wires in there. But I've discovered these little guys. They have little push button things. So that's the end that I want to connect to my power supply. And again, the white wire was plus, so you push that in, push the wire in, and the green was minus, so I'm pushing in the black one, and I'm sliding the wire in. This is a 22 gauge wire. So when I plug my 12 volt transformer on there, it'll be the same as if I were pushing the button. So I have a AC transformer. So when I plug that in, the transformer here puts out 12 volts at 1.5 amps. Now I don't need that many amps to fire that solenoid, but if I'm running other things like lights and maybe some other solenoids, having that is good. So when I connect this up, let's just do a quick test. Can you hear the click? Let me bring you in closer. You might be able to see that there's a status light on there. The other ones that you get, they may not have status lights. In fact, this one does not have a status light. But that's kind of nice. It lets you know that that's turned on. It's energized. So let's connect the air up to it now. When I plug this in, the cylinder will fire. What I have here is a homemade remote activator, and you push the button here and it will connect the power supply through and then go to the solenoid. So if I do that, if I connect up my 12 volts on that side and I plug in my solenoid on that side, then this is a length of wire that I can be put somewhere, and I can push the button, and when I push the button it activates the cylinder. This is how I put together the hand trigger. So the plan will be that I'm going to connect the wires up. I have some pieces of heat shrink tubing. You can buy heat shrink tubing in a kit, different sizes. I just found the size that fit comfortably over the terminal. And we'll get to work. First thing I'll do is I'll wet my soldering sponge. And the soldering iron is up to temperature. Let's get some wire. And what I want to do is I want to strip the wire. This is 22 gauge wire, so let's see here. Where is 22? Is it 18 or is it 22? Oh, it's 18. Strip off a little bit, not too much. And what I'm going to do is I'm going to do something called pre-tinning the wire, which means I'm going to take some solder and I'm going to just put the solder down on that. Like so. Wipe off the excess. To make it easier to solder this wire, I'll use something called helping hands. You don't need those yet. I'm going to hold one end that I'm not soldering with that. I'm going to bring over. And the important thing to remember to do is to slide your heat shrink tubing on before you make the connection. I'm also going to hit the terminal. Now, these are plastic bodies. If you dwell too long with a soldering iron, you will melt them and you'll break your switch. So I'll do that with that. Put some solder on there, and I'm going to. Now you could go through the eyelet and make a little junction. This is just going to be a tack. They call it tack soldering. You hold it in place, let the solder cool down, and then slide your heat shrink tubing over it. And then we use a heat gun to melt that, or to shrink that. And I'll do that for the other terminal. And what you should have when you're done is a push button switch, and the two wires are attached to it like that. Now, obviously, if I wanted this to be in another location, I would use a longer wire, but for demonstration purposes, I'm just keeping the run short. I should also point out that you need to get the switch that's rated for the current that you're planning to pass through that if you're planning to just connect it directly to the prop. I would not run high voltage like 120 through this because that would be a little dangerous. 12 volts, 5 volts, whatever, that's fine. Keep it low voltage. Now the other end of this wire, and now I have a red wire and a black wire, and I'm just going to strip a little bit off of there. I'm going to even it up there. Once again, 18 gauge. And then I'll strip this black wire. I'll use that as my ground wire, or my minus wire. And I'll give them a good twist on either end. And I'm going to screw them into the terminal strips. Now, some might think, well, why don't you go ahead and tin the wires? It makes them neater and everything. Yes, that's true, but I'm told that that makes the wires have a tendency, if they're bent back and forth a number of times, of being stiff. It'll metal fatigue and break the wire off. So the temptation to tin these wires, I would avoid that. So this is what we have. We have a male and a female connector on either side. We can plug our 12-volt power supply into one side of it. The button will connect the positives together. The minuses are already connected. We push the button and it'll send the 12 volts out to the plug. I have a way to test this on my bench. Let me get that and show you what that's like. So what I have here is a little block that I can plug in a voltage source and light up a corresponding light, like the green light or the yellow light. And what I'm going to do is I am going to hook up the button. So plug in the power supply and plug that in where the power supply was just at. When I push the button, the light comes on, which means that if it were a solenoid, then that would fire the solenoid and the prop would fire. So then I have a manual control. Now they do sell these types of switches already made, so you can clearly make your own, but if you want to get one that's professionally put together and it's in a body that will prevent the wires from pulling out, but you can obviously buy prop triggers. The next topic regarding solenoids is that, even with low voltage coils, they generate a high voltage back EMF spike when the coil is de-energized. This spike can be coupled through the electrical system and can cause loud pops on the sound system, which isn't good for the speakers, and or cause erratic prop behavior. I have a bench power supply of 12 volts, and this solenoid wants 12 volts, and if I connect them up, you'll hear you'll hear it click. But it also should point out that if I reverse the wires, and I'll hook the black to the red and the red to the black, it still clicks. Okay, so let's take a look at this thing on the scope. When I connect it up to the scope, let me connect this up to the scope. So I'm going to connect the ground to the ground, and I'm going to monitor the voltage on the scope. And I'm going to do the same thing. I'm going to be touching the red wire like that. So here we are looking at channel 1, and this is a trace of the voltage. Right now, the center point is 0. Anything above the line is a positive voltage, and anything below the line is a negative voltage. I'm set up at 50 volts per division. That means that every line from here to here is 50 volts. Going up, plus 50 volts, and going down, negative 50 volts. And I have it set up so that we can see what happens when I energize the coil and de-energize the coil. So first, let me connect it up. And we have a positive 12 volts. And look at that. Let me see if I can stop it. So what we can see here is that it went down negative 50, negative 100, about 125 volts in a minus direction. So that is indication of what they call backwards EMF, or a reverse voltage. So what I'm going to do is I'm going to connect up the flyback diode. Now, normally you want plus on this end, and where the silver stripe is, you want the minus. But we are going to do it the other way around, because we want to snub the negative voltages. A typical approach to block these spikes is to add a flyback diode. The diode is installed in the circuit with the polarity opposite to the normal current flow, effectively providing a low resistant path for the reverse voltage spike and thereby protecting the circuit components. Any general purpose switching diode that can easily handle an amp will work well to quench the reverse spike. I'd recommend a 1N 4001 or 4002 or 4004, etc. I use whatever diode I can find in my electronic parts. However, I would not use a signal diode such as a 1N 4148 or a 1N 914, as they cannot handle the current. So let me resume. This is what we were seeing before. And let's turn on the scope. So now it's running. And now I'm going to energize the relay. You may hear it click. That's pretty good. Okay, I'm going to go down to 5 volts per division. Okay, and you can see just a little bit of an undershoot, but not 120 volts undershoot. About 0.6 volts. But now that means that the reverse EMF has been shunted off by the diode. Okay, well that's a quick introduction to things. Let's go build some props. Feel free to leave me any suggestions or questions in the comment section. And while you're at it, please like and subscribe because it really helps grow the channel and lets me know that you're enjoying this content. Also be sure to hit that notification bell because you don't want to miss out on the next exciting episode. Thanks for watching.